guys, regardless of my lack of knowledge of times tables. Any questions, guys, about that? That's fairly easy. Okay. What about this second one? And I know that we already did the one with rational. I'll make sure I fix that. All right. But does x plus 1 divide x squared minus 3x plus 2? There's a couple ways that we could be either show or disprove that. So, what were you
So
thinking?
do the synthetic deviation.
We could do long or synthetic division. I always just do long division because it's a little bit easier if there's a coefficient in front. Sure, we could do long division with this. Okay, so let's do that. And then I'll show you guys another way that potentially might work. So just in case you guys forgot long division because you haven't had to suffer through it, although if you're taking Calc 2, you probably are suffering through remembering how to do that stuff. Remember to do long division, guys, you just look at the first terms. Okay, so I'm going to look at x, and I'm going to look at x squared. And then I think to myself, guys, what multiplies by x to give me x squared? So guys, what does multiply by x to give me x squared? Just x. Good. So we have an x here. We distribute the x to these two. So x times x squared. X times 1 is x. And then don't we flip the signs around? Okay, so this would become a minus x squared and a minus x. I always tell my students in basic algebra, you know you're doing it correctly if the first terms negate. In other words, they go away. Okay? Because that's the whole purpose of division, is to figure out how many times each of those first two terms go into each other. Okay? Just like regular division, you bring the rest of the stuff down. So we would have negative 4x plus 2. And then don't we just do the whole thing over again, right guys? Okay? So, in this time, we're trying to figure out what multiplies by x to give us negative 4x. So guys, what multiplies by x to give us negative 4x?
Negative 4.
Negative 4. Negative 4 times x, negative 4x. Negative 4 times 1, negative 4. We flip the signs over. Notice that the x's cancel out, and that's exactly what we want to happen. And then we end up with 6, and nothing else to bring down. Okay? So, what is 6, guys?
The remainder.
The remainder, okay? Guys, if you have a remainder, what does that mean? Not divisible, right? That's the very definition of divisibility. Divisibility means that there's no remainder. So because, we could just say, I think we would write this as what? Plus 6 over x plus 1, okay? Because there's a remainder, or we could just say right here, it is not divisible since there is a remainder. Okay? We don't even have to write the 6 over x plus 1 if we don't want to, but that's good enough. Okay? So sure, we can always use long division. Long division always works, by the way, to prove or disprove divisibility. Okay? For this particular problem, what's another way that you guys could show that this does not work out? So,
Maybe the factor.
yeah, we could go ahead and we could factor this animal, right? So, couldn't we go ahead and just factor this trinomial, and we could see that it's not a factor? Okay, so this is one method. If I was to ask you guys to factor that x squared minus 3x plus 2, what would this animal factor into, guys?
X minus 1, x minus 2.
And clearly it doesn't contain a factor of x plus 1, right guys? So that's a little bit faster way. Okay? Now, what's the problem with relying on factoring all the time? Yeah, we have these things called prime polynomials, right? So that's why I said long division will always work, okay? Because you can always do long division. You can't always do polynomial factoring. Okay, go ahead.
So when you factor, if both of them didn't come out to x plus 1, is that, or does just one of them?
Just one of them needs to be, because all you need is one factor of x plus 1.
Okay.
But clearly there's not even one of them, okay? So you just say, neither factor is x plus 1, so not divisible. Alright, so that's fun. Yeah, how many of you guys, when you suffer through Calc 2, you remember those partial fraction decompositions and you had to do long division? Yeah. I'd rather saw off my arm with a rusty razor, but regardless. Guys, any questions I can answer about how you guys would show divisibility, whether it be with an integer or be with a polynomial? Okay? Okay, nice and easy, right guys? All right, so next thing we need to do is we just need to do a few direct proofs, okay? So, one of the most important proofs with divisibility is the transitivity law, okay? I believe we took a look at transitivity when we had, and it was a while ago when we did the basic rules of inference. We had transitivity that way. Transitivity is one of the most fundamental rules of mathematics, and it happens a lot in math, okay? We actually have a divisibility transitivity rule, okay? Transitivity says that if A divides B and B divides C, then A must divide C as well, okay? Now think about this, guys. Think about numbers that we divide. Like let's say for instance, okay? Isn't it true that 2 divides 4? That's correct, right? I would also say that 4 divides 8. If that's true, then it must mean that 2 divides 8, right? That's what transitivity says. And we know that that's true. There's not one person in this class that doesn't know that 2 divides 4, 4 divides 8, thus 2 divides 8. And that works every single time, okay? As long as the first 2 statements are true. Now, our job is to be able to prove that true for any integer set such that it's true, okay? So, everybody understand what we're trying to show, guys? We're trying to show this rule is valid, okay? So, let's go ahead and use our direct proof. Well, let's try to. Apparently not. Okay. So, first things first. Oh boy. It's like a ransom note. Jesus. Bring 1 million cookies. Oh, it's gone. Real nice. All right. Let's try it again. There we go. Okay. So, we need 3 variables, right guys? That's so obvious. So, let's let A, B, and C be elements of what set, guys? With divisibility, are we working with rationals?
No, integers.
No, integers, right guys? So, let's let A, B, and C be integers. Okay. I'll put in brackets. A, B, C, arbitrary but particular, yawn. And there's one other thing that we have to say before we can start using definitions or substitutions. Okay, Don.
The denominators can't equal 0.
That is true. We should say that A and B should be non-zero. We'll get to that in a moment, okay? So can you hold on to that and remind me? Because that is very important, okay? So what's something else that we have to say? Don't we have a conditional statement, guys?
Oh,
Doesn't it
yes.
say if A divides B and B divides C, right? Don't we have to make that assumption? Anytime it says if, you have to assume that that's true. Didn't we do that the other day with perfect squares? We said if they're perfect squares, right? Then it plugged into that formula. So we're going to say such that A divides B and B divides C. Okay? So again, anytime you see a conditional statement, okay, then we have to make sure that the antecedent is stated somewhere in that proof, okay? And Donnie, I'm going to say what you suggested as well. Also, A and B should be non-zero, okay? So, we'll just say, comma, A, comma, B, non-zero.
Why didn't
Oh, because those are the ones that are eventually going to be in the denominator, right? Because it says if A divides B, and 0 doesn't divide any number, ever, okay? Then, so if they're on the right, if they're on the left-hand side of that divisibility bar, you should define them to be non-zero.
Why not C then?
What's that?
Why not C?
C will be
Oh,
new.
because C is what we're dividing into at some point.
C's never on the left side of the
Right, yeah. That's the only ones that are in the denominator. That's actually a really good question, and you guys explained that very nicely. Okay. All right. So, does that make sense to everybody as to why we have to assume that A divides B and B divides C? It's an if-then statement. Okay. So, because that's true, don't we now use the definition of divisibility? So, by definition of divisibility, we can say 2 things. We can say something about B, and we can say something about C. Okay, so by definition of divisibility, B is equal to something, and C is equal to something.
So B is a multiple of A, right?
That's correct, okay? And remember, didn't we say that we're going to use, in particular, this first rule right here, okay? So B can be written in the form of AC, but we don't want to use A because we've already defined A. So B could be equal to what, guys?
XC
X,
or MC?
XA.
X, sorry,
Okay.
X.
So B would be equal to X times A, because A is a factor of B.
B.
Okay, that's what divisibility means. Does that make sense to everybody,
Mhm.
guys? If A divides B, that means some number times A is equal to B. Okay. What can we say then about C, since B divides C?
So you equal to YB?
So we could say that this is equal to Y times B. Because again, B is a factor, which means that if you have two integers that multiply, they should be equal to C. Okay. A couple other things we should say. Okay, so what should we say at this point now that we've introduced new variables? Yeah, we definitely have to say that X and Y are integers. Okay, so. We don't have to say they're non-zero. Everybody good with that, guys? Any questions? That's our definition part. Okay. Now we have to do the substitution part. The substitution part is going to be very, very easy. Okay, so this is one. Step 2, by substitution, what are we trying to show, guys? We are trying to show that C contains a factor of what? A.
Yeah.
Correct. Okay. So shouldn't we substitute maybe into C, if we could?
Yep.
So, by substitution, C, which is equal to Y times B, is the same as C equals what?
Y times X over A?
Y times
That's XA.
Isn't it true that B is equal to XA? So we can just go ahead and substitute there. Okay? So, we're going to say that C equals YB becomes C equals Y times
XA.
XA. We're just substituting back in for this YB right here. So this is XA. Is that clear to everybody, guys? We're just substituting, and that's only because we need to figure out, because remember, what we're ultimately trying to show is we're trying to show that A divides C. Okay? So we're picking on something that contains the C. Okay? Well, guys, aren't we almost done with this? Because what do we see clearly about C? It contains a factor of A, doesn't it? So could I not rewrite this? Okay? I could just use an associative and commutative property. Okay? I could just say, and we don't have to do this step, but I'm going to. By the associative property, isn't it true that C is going to be equal to quantity Yx times A? Okay? I mean, if you got a real ball buster for a teacher, they'd want you to show that, okay? And I don't mean that like, you know, in any sort of negative connotation. It does happen, okay? So they, yeah, maybe somebody like that. They might want to see that. Not saying that they would. All right, guys, what do we know about Yx? It's an integer, right? Which means that Y times X could be written as M, N, P, whatever you want. By closure, right? So by closure, C is going to be equal to, you guys want to use M, why not? M, A. Or M is an integer. All right. Let me ask you guys a question. Is C divisible by A? Yeah, because it contains a factor of A, right? In fact, isn't that the very definition of divisibility right there? The very definition of divisibility says that you have one integer is equal to some other integer times what you're trying to be divisible by, okay? That is the core definition of divisibility. So the algebra in this was very, very little. It was a little bit sneaky though, right, you guys? Because we didn't necessarily know what to substitute into. okay? After we do another one, it might be obvious as to what to substitute into, but here's my suggestion, guys. We're not done with this, we're almost done. My suggestion, guys, is to always substitute into the right-hand side of what you're trying to show, okay? So if you guys, when you guys go through your substitution step, always on the right-hand side of whatever it is that you're trying to prove, okay? That makes it really easy. Okay, so let's go ahead and finish off this proof. Can't we say that by above, or thus, C is equal to MA and contains a factor of A? Which means it must be divisible by the very definition of divisibility. Okay, so thus, A divides C by definition of the worst word in the world, divisibility. There's 5 eyes in it. It's like my mother-in-law, she has 5 eyes, always watching me. Why are you drinking beer? It's because you're my mother-in-law, that's why. I wouldn't have to drink if you weren't. Regardless. Did you get that on film?
Yep,
Good.
I'll send her.
Yeah, send it to her. If only it was appropriate to show my ass, that would be awesome to show that to her as well. Regardless. Okay. Guys, any questions I can answer for you all about how we're going to approach this divisibility stuff? I know it's a little bit different than some of the other ones that we've seen, because the substitution isn't as obvious, okay? Hopefully after we do another example, it'll be a little bit more obvious for you guys. Okay? So let's tackle another one. Okay. So, for all A, B, and C integers, again, if A divides B and A divides C, then A divides 10B minus